So yeah, I'm going to be talking a bit about fonts first, or typefaces, and we're going to go a bit through history and see why we ended up in the situation we are in now, and then we're going to explore that situation. Oh. Yeah, so fonts started, or typefaces started long ago with cuneiform, which is probably the oldest one that exists because it was made of clay tables. And even then, you can still already see, like, we have parts of fonts that look alike, and they match together, and you get a word. So that was like the first step. Then we began to look at runes. With runes, you began to put a bit more feeling into fonts. Like if you look at runes in Denmark, you can specify what, like you can see, like, if two rune tables or tablets are made by the same person and such. And they also invented a new thing they call, like, it's usually called bind runes. So if you look very closely on this picture, that's probably not good. You can see that this one, there you have three prongs on, like, it's a letter that doesn't exist, but it's actually two letters that is put together. Like this has been used a lot, like not so many years ago when they made the Bluetooth logo, for example, because they put like what looks a bit like a B together with what looks a bit like a T in a bind rune. So that is probably what we today would call the ligature. You match two letters together. Like in Danish, for example, we have the A and the E matched together to have become its own letter now, but it started as a ligature, as a A, right? So sometime later, some guy from Germany comes around and figure out, why don't we take these letters and like put them into, like, make them out of lead and print some books from it. And that turned out to go really well, and like that revolutionized the industry. There's been some movable types before. There have been some in Korea and some in China, but they didn't really gain as much traction as when Gutenberg came around. So he made a very, like, his big work was a Bible. So it's set in, if I remember correctly, 42 lines on each page. It was set with a font that I think it's called Textularis or something like that. It's not very readable now. You probably call it Gothic fonts or Fraktur now. But if you look here, we can see there are letters that are ligatured together. Like, for example, if we take a random place, you have like I's, H-I, for example, or R-I are ligatured together. So you need to remember, you had a single, like, you had to take all these fonts and you have to place them in a very small. These letters are not very big. So this was all the types that Gutenberg had. And you can see there's a lot of them. There's even duplicates, like there's 2 A's and there's 5 T's. Like, why did he need so many? Like, for the first, it's faster. And for example, some types can break easily and such. But he also used it to make, like, the page nicely fit. So you can see the white margin is very tight. It goes, like, straight down. There's no like rivers, you call it, or there's too much spacing between words, as you usually get in, like, articles you read. Like, if you know about them, you spot them all over the place, and they take you a bit out of it. So how do you combat that? There's a few things for that. So the first thing I will talk about is kerning. It's also the other reason you have ligatures. So if you have 2 letters that, like here, for example, A and V, you want them to put them closer together because else they look very far apart. So you say, let's move them a bit closer together. How do you do kerning in movable types? You take some of the type and you cut it off. Or you mold a bit larger type and you have to file it afterwards. It was a very slow process. Here's another example. So this is how you molded it, and you had to file it down. And it took long, but it gave some very nice close letters together. But there's an issue with these. These can break, for example. So and they're very small again, as I said. This is probably a bit large even. You have to think 6 points or something like that. This is a few millimeters large in width. And you had to place all these down by hand back then. So one of the things you did was ligatures. So here we have 2 different ligatures. We have an F and I and an F and a long S. Yeah, I think it is. And so you could both move them together, and you can also change how they looked. For example, see if you look at the F and the T, the line has gone all the way through. So you took a letter out and you put another in. That you took 2 letters out and put one in, or one new mold in, and that was the birth of ligatures. There's plenty of other ligatures used, in English, for example, they use the YE ligature a lot, which is why you say YE, that's the reason you say the old. It's because the TH, it's like a soft D for they put them together and it look a bit like a Y. So it's a different letter. But yeah, so sometimes later, this is now probably in the 60s, you came up with computer fonts. So in the first time they did it, so the printer had fonts. You also had printers that had wheels with metal types on them, but they were very, you could not change how they looked. You may even need, if you wanted to have a ligature, you needed 2 different, you needed a special thing installed in your type. For example, the most famous one is probably PostScript. PostScript came with 26 types, and you couldn't choose any other than them. But then around came someone called Donald Knuth. Oh, I skipped over this. We also did bitmap fonts, which are not nice to read on paper. But yeah, Donald Knuth came around. He was working on his tech thing that you may have heard about. And he also made something called metafont, which is a language a bit like it, but it could be used to describe letters. It could be used to describe letters in a programmable way, so you could scale the letters. You couldn't do that before. You had these letters and you had these sizes. But so he said, let's make a programming language that does it. He made it for his own use, and it was one of the early ones before. So what was PostScript types became PostScript. They call them just PostScript types version 1, I think, and that later became OTF, and TTF is also a bit like it. But already metafont, it could be used on a printer where you only before had pre-programmed types. You could use any, you could make your own types. You could add mathematical symbols, which was one of the reasons he did it. And it already had support for ligatures by substitution, but not other kinds. So PostScript type 1 is the precursor to modern type systems. And it was the first one that was made for screens. So for screens, you want something called hinting that makes scaling better, at least on lower resolutions. It was used in the first Macintosh, and OpenType is the direct descendant. Apple uses TrueType now, and that was just because they couldn't agree on pricing with Adobe, so they made their own. So here comes the interesting part. And so half-bus is that's a C++ library that is made. Like it's quite old now. I think it's like 15 years old, if I remember correctly, and it's used widely. It's used like in Chrome. It's used a lot, and everything Chrome uses has to be vetted quite a lot. But yeah, so what does half-bus even do? So you give half-bus, you give it a font, and you give it some text it has to shape, you call it. So it has to look up in the tables and see these two letters has to be moved a bit closer together, and these two have to be exchanged with a ligature, and it also does some kerning and stuff like that. So it's a lot of tables. So here's some examples of ligatures and stuff you can do with the table that's called the D subtable, where you just have a list of things, and you have a list of items you want to exchange for other things. So, for example, F and I, if they're together, you want it to be an Fi ligature. You can also use it to have different kinds of a letter. For example, the ampersand over there. It's also used for things like if you have vertical text, you want to use a different type of parentheses. You don't want to use, that would look strange vertically. So you want to turn them around, and it's also used in I think this is Urdu. I hope I'm correct there. Like to put them together. So you can also do it for larger stuff. Like you can use it for only two, but you can also use it for many, and you can use it for, you can even do it recursively. So there's a lot of stuff there. That's one of the tables that is interesting. The other one is the GPOS table, which is that is what we use for kerning, but also for positioning stuff like dots over a O there, and a very big text, for example, so it doesn't look strange when you read it. That is the two tables that are commonly used. There's also so OpenType also defines like a lot of movement and placement of dots that for different languages, and that is like a big table. That is also a thing that half-bus has to implement. So where does WebAssembly come into this? So half-bus, I think earlier this year in the summer, they released a new version where they had experimental support for WebAssembly, and Rust can compile to WebAssembly. So I had a look at it. It's a very simple interface. It uses extend-C, as you can see, so it just calls into half-bus. It places the WebAssembly code in a table on the front. So if half-bus has WebAssembly support, it runs the code there. It's still experimental and not enabled by default, and that's probably a good reason for that. So this is the main entry point. You just have a function. There's a bunch more functions I skipped over, but you have a function that sets the content of the buffer. So you give it two lists. This is C list, so it's mutable pointer, stuff like that, and you give it a length, and it will just put the content there. But let's look a bit more into those. So these are the two ones. They're split up in a bit. So you have the cliff info that contains the code point. So the code point is, in Rust we would call it the char. Half-bus is a bit special. It's not only UTF-32 code points, but it's actually also the same one that is used for the cliff, which is a single character. And they are two separate ones, and not always the same. For example, A in UTF-8 is not the same as in a font. In a font, A is usually 0 or 1. So if you're not careful, you can be a bit confused by that. But yeah, so this contains some different things. Only two that are interesting. One is the codepoint and the cluster. The cluster means just the letter that it represents in the original text. So if it is an FI ligature, it will represent the F and the I in some way. That is so you can put the cursor correctly, I think. The other one, this is the one that is about the ligatures. So the other one is about positioning. So you have X and Y advanced and Y advanced. That is telling me where to draw the next character, and then you have X offset and Y offset, which means where to move this character. They move it a bit around to make it nicer to use. They have this flex. I'm still not sure what to use that for. It just says you can use it for anything. I don't quite know what that means. I think you can just put stuff into it and it stays there or something like that. So the first thing I did, I thought, as you do with all good things, you implement Bad-Apple in it. So Bad-Apple is a Toho series animation, and it's been pretty popular in the demo scene. So if we go over to the font here, you can already see this one looks a bit suspect. There's a character there that is probably the case of a one-off and small error. But if we add another dot, oh, that looks a bit bad. But so if we add some more dots here, you can see that suddenly the animation starts, right? So I couldn't figure out how. I couldn't figure out how to configure this one to run at 60 Hertz, but it runs quite nicely, and it's just like it's a bit of a big ligature. That is at least one way to see it, but it's probably more correct to say that it's a small program that just says you have written 3,000 dots. Now show the 3,000th frame.
Does it go backwards?
Of course it does. So you can also reverse it. And I made a small blog post about this, and a lot of people was complaining about that this is not a real animation because I have to hold down a key. But yeah, it's close enough. I tried to see if you could do animations with half bus without with calling the C functions multiple times, but that just crashes it and does strange things. So that was my first idea. And also the thing, this is possible with gsub. That's the small issue that most engines have a quite small limit for how much you maybe could. Yeah.
How are the frames stored?
Okay, so these are stored in a font. So there's a font where I just said. So Unicode specifies a free use area. So I just put 6,000 frames into that free use area, and so if it's not a bitmap. Yeah, it's vectorized. So I probably didn't write good enough guide on it because I saw on GitHub there's somebody who saw my blog post and then implemented it himself because I didn't say it clear enough how I did. So you can find it on GitHub if you look for it. But yeah, it just places a frame on it. So it has some offset there, and it places the frames from that. That's 6,537 frames in this animation. So you have to hold down dot for a very long time. But yeah, it's also possible with gsub. So I thought, what can I do that isn't possible with gsub? So as Van just said, so I made a computer game. So what is possible in the font here? So what do I need for it? I need to be it needs to be fully deterministic because it has to run for every new character, and it does if it wasn't deterministic, it would be a different one every single new character you type. So it has to be deterministic. It has to be fast to run because if you're like 1,000 characters in, you have to run like the 1,000 characters worth of code for every new character, which gave some issues. It has to be simple, because like, at least you can do colors, but at least with this I only did black and white, and I wanted it to be simple and well known. Yeah, and it has to be able to run in steps. Like, it wouldn't be fun to run some game where it was continuous. So I wanted it to be in steps. So I thought, what game is good for that? So Tetris was the first thing that sprang to mind. So Tetris is a well-known game, everyone knows it. So I implemented a small Tetris that was deterministic and could run rather fast. This is very simply implemented, but I just had a game board that was a bitmap. I made some very simple deterministic random, pseudo-random function that XOR shifts. And I had a small function, a small trait that I wanted to display it with. Like a simple implementation of it was just to print out like the 10 bytes in binary. So I could see it working first. But yeah. So when I want to place this on when I want to actually place this on the screen, I want to check, is there a block somewhere? So this one checks if there's a board or if there's a block at some point. This is not very pretty code, but it works just about. So I made a different font. I took a different font and I put a single pixel in it. I could have used something like a full stop, but I added a pixel because I wanted something that I knew the size of, because then I could calculate the X offsets better. So I had some predefined sizes of this pixel, and I could move it around. So suddenly I could move this pixel around on the game board. So, and I made an implementation of display that just ran through it all and displayed it. So that's my other demo. So if we write Tetris and then give some seed, we get a Tetris piece.
So this is a ligature. Tetris 42 colon is the beginning of a ligature.
Yeah. So yeah, this is the beginning of a ligature, and then you can like play it and and yeah, like if I make a mistake, I can just delete a bit and go back again, and it clears lines and everything. So this is very smart, and I added a way to quit it, so you can even play. Of course. So we can play 2 games of Tetris.
Go to the other part and
oh yeah,
there. Yeah, you just go to the other part of the screen.
Oh yeah, I tapped the wrong place. so yeah, so you can play two games of Tetris if you want that. So yeah.
Or you could finish your homework.
Decision, right? Yeah. So I think this was like the top of the presentation, and it's all downhill from here. It's not very much like so my actual goal was to make a Game Boy emulator in it, but I think the timing requirements are very hard to hit, because like most Game Boy emulators have a hard enough time reaching like 20 times speed, but I probably need like 100 or 1,000 times speed for this, because you have to do all the state before every single time. so it would be very slow to run. I did implement the whole CPU before I came to that realization, so maybe I got back to it at some point. But yeah.
Maybe you can collaborate with tools about text games.
Yeah.
Have you thought about doing chess? You could even use like chess notation.
Oh, that's a good idea. That is something you probably could do.
Any game.
Yeah.
You just copy and paste the game.
Exactly.
Yeah. Initial like variables to like start the game. Have the whole board.
Yeah, I think with chess, one of the issues is that a font is usually very small, so you would have to use a very big font. But it's probably possible with chess. I didn't even think about that. And since fonts are usually vector-based, you can scale it to any size you want. So that is something that is possible. But it's also possible to use it for actually useful things. So Halfboss made some examples themselves, and it's they have some really good examples. They have some examples where they have like a font that is made out of small dots. They have some examples where they do stuff they couldn't do without it, which is the most interesting types, of course. But yeah, I think that was everything. So, is there any questions?
Do you have an example of what they added? Like, what could they do in that example you said they shared?
So one I remember at least is so. I think that is impossible to do with normal font is to order which one is typed first. So if you have a very big font that is overlapping, you cannot order them. So if you write OO or like ON and you want them to overlap, but you want the O to be in the front, that is impossible to do with G sub and G pos, but it is possible to do with this. There was also some examples of Arabic types where you have to position the dots very exact, which is not possible with normal G sub and G pos rules.
How did you create like the different codepoints for your custom fonts?
So I used so I can't even remember what the program I used for the Tetris font, but for the other font I used FontForge, which is open source, and it's nice to use.
Is this how modular?
Close. Emojis are kind of ligatures, especially when they are. So emojis already they're like one code point, but you can just put emojis together, for example. But they often use a character that says these two has to be put together in the middle. Or for example, flags are just like the Danish flag will just be a D letter and a K letter next to it, or a D flag represents emoji letter thing and a K emoji letter. Yeah. So in a way, this is like ligatures are kind of what some emojis are. Yeah.
Is it only a matter of time until something like Google Chrome is actually compiled with Parkbus that can do this?
I think it's probably so. Example I saw. See if I can. So if this for example panics, it just fails completely and will just put all the letters in the first position. So you have to write code that doesn't fail under any circumstances. At least you hope it doesn't do. It's sometimes a bit hard, but you have to do that. And they also have to be sure that this is not exploitable, because it is a quite big, like it's a big target. But Wasm was built from like the idea behind Wasm was that it should be safe to run. So currently it uses like a small C Git for the background, made by the same people who make, or I cannot remember, but it's a small C one, and they have to ensure that it's safe to run before they compile it into So like if you go into GitHub and search for Bad Apple font, you can find a repository not by me, but by another guy, and he also made a way to build half-boss with it and all that, because I didn't do that back in the day.
How large is the Valdemar font if you need to embed all the frames inside the...
The font files are not very large. We can see if I can find them. So this one is the largest one. It's 5.7 megabytes. But the Tetris font is the same size as the normal font. If we look at the actual binaries, maybe, if I can remember where I put it. So this is the bottom. It's only 50 kilobytes, so it's rather small to embed into a font that is much larger already. Like the font is 306 kilobytes, so you can probably see it, but it's not much. This is a very cut down font. It only has most normal letters, I think, like Latin 1 or something like that.
Just so I understand correctly, you are mostly using half-boss as like a rendering engine, right? In the way that you are dynamically choosing what to send to it.
Yeah.
With your WebAssembly implementation.
Yeah. Yeah.
So this is not actually possible if you just were to use any normal font rendering engine for it. Like
no.
You could not put this font into Word and then do the stuff.
Exactly. Yeah. You have to use half-boss for this.
Yeah.
Like G+ and G sub, that is enough for most people. And you can also make games in that there exist something called Valdemar, which is a Pokemon-like game inside of a font that actually renders in browsers and such. And that is also very interesting, and you should all look up at that because it's very nice.
Yeah, I might be misunderstanding, but is there a limit to how many characters you can put in an old style font? Because technically, couldn't this Tetris game also be some kind of ligature?
Yeah, so
you find a way to express all the game states.
It is possible, but you run into the issue that there's a recursion limit very fast. I don't think I cannot remember out of the top of head, but it's pretty low, maybe 12 or something like that is the recursion limit. And if you want to make every single possible Tetris game for some value, it gets very large. But it is possible in some way of using the word possible. I don't know if anyone of you spotted it, but if we use 0 in this font, every single type will be so it's not perfect. You will only get these stuff you can do still about that.
What happens if you change the seed?
-1.
It's U64, so no minuses. It plays the whole game.
So what happened when you press 0?
What happens when I press 0? It's just that this function doesn't work when it's 0.
So you export this with a 0 day.
Yeah. Yeah.
What happens if you lose?
If I lose, that's probably one of the things that doesn't work quite well. So.
Sorry, I withdrew this. No.
Oh, I don't know what is happening with that font. Let's make a new one. and it just so it should just end the game.
Just keeps dropping stuff.
But I made it so you have to end the game with a queue, and then you can start the new game. So it just doesn't play anymore. I could add like a end game screen or something like that, but I didn't do that. What?
What's the release date?
Soon. Yeah. I just have to clean the repository a bit because it also has the presentation and stuff like that. Also, I should probably show the credits for all the images. But yeah, also it's typeset with Rust, which is important, or with TIPST, it's called. So.
Oh, is it?
Yeah.
Getting a lot of hype the last few days.
Yeah.
Is it TIPST or TIPST?
I just copy and release them.
I call it TIPST. Yeah.
It's easy to say that like.
Yeah, but yeah, it's a bit of a pain to use. Yeah, like take. But yeah.
Any more questions? Or are you still picking up your jaws from Alice? So with the Bad Apple font,
Yeah.
you said that the frames were in this like special part of the Unicode segment. That means that you had to use up a code point for every possible frame.
Yeah.
But for Tetris, it sounds like
I only used a single extra code point, and I could just have used a full stop or something like that.
okay. So it sounds like that you can like output arbitrary images, and they don't have to be a code point each.
Yeah. You can do that. Sure. Like you just have to be able to build it of other cliffs.
Oh, so you're just using like a square?
Yeah. Like for Tetris, I use a pixel, which is just one that is, I think it's 4 units times 4 units, because then I knew how big it was. But I could as well have used a full stop, then it would just have rounded edges, or maybe a ASCII square or something like that. Yeah. Yeah.
What is actually rendering this game? Is that a WebKit browser or something like that?
I actually don't know what is rendering. It's Fun Goggles, and it's some, I don't know if it's made by HalfBus or something like that, and it has a you can have different, you can actually see what characters this is, and it's a lot of characters. I forgot.
There are these font style properties that modify how the type looks.
Yeah.
One of that is, do you get any of that for free? Can you change the color? Can you like make it bold or italic or anything?
So yeah, I don't think this font has any of that, but yeah, fonts that can do that exist, but you have to implement it. It's implemented. Yeah, you have to do it. I think Font4 can do it, for example. But yeah, the examples in HalfBus is more interesting if you actually want to see the fonts in use. So the examples there are more interesting for that. There's one where they make it more bold, I think, change the shape of the letter, for example. So we can also do that. Yeah. If Chrome ever decides that it's a good idea to enable the flag that is called like a WebAssembly support for HalfBus, then it would, yeah. But it's probably an open discussion. People are scared enough of what fonts can do without this already. So
it's job security for security engineers.
Exactly.
It's fine. Go make more apps in fonts. It's fine.
Yeah.
And lastly, do you want to explain what grapheme clusters are?
I can do that. A grapheme cluster is something like this. This is, so it's just more characters put together. No.
Yeah, right. So because I was learning with both Swift and Rust and the other language, like, okay, we don't treat a character. A character is like a grapheme cluster, which means an emoji.
Yeah, no. So in Rust, so a char in Rust is a U32.
Yeah.
So it's a single Unicode code point. A grapheme cluster is larger than that, I think.
Yeah.
If I remember correctly, it is, for example, if you have an O with 2 dots over, then it's the same grapheme cluster.
Right. Yeah, but I think that's what messed me up in Swift and other languages. Is that like something like, no, it's longer than one character, but it's not. It's one character.
Yeah. So in Rust, it's more the other way. It's often shorter, except if you use the char. Like you always, like if you want to go by character, you want to use the char. But if you want to go by grapheme cluster, you cannot do that with the standard library. But there's some crates that can do that as well.
But I guess that's the difference between ligatures like FI and emoji.
Yeah. So what do you mean the difference?
Well, one of them is one grapheme cluster, and the other is just 2.
No, 3, probably. Often.
Yeah. Emojis often have a binding character in the middle.
I thought that each emoji was a grapheme cluster.
Yeah. Each emoji is a grapheme cluster, but an FI ligature, I don't think that is a grapheme cluster.
That's just an F followed by
Yeah.
Right? That's specific to the font.
Exactly.
That's nothing to do with Unicode.
Yeah. But yeah, Unicode is also very complicated. You could probably do a whole talk about that as well.
We have an expert in the audience who did a talk about that a year ago, I think. Was it
a couple of months?
Was it?
Like a year ago.
Was it with Google?
Yeah.
That's like half a year ago at least.
A whole year has a big difference for you.
Was it a Google? I was at that one. I cannot remember it.
But that was a path.
It wasn't even about Unicode. It was actually about paths and processing the whole time. It's just ruined by Unicode. So it takes up most of it.
Detour. But that was very good. So yeah, if you want to learn more about methods, we have that talk as well. All right, that's unfortunately, very unfortunately, all we have time for with this. Because I want to see way more mad science in this calendar. But yeah, thank you very much, Valdemar, for that.
Yep.